Hello Year 7, it's Ms Redmond here again with another summary PowerPoint for the particles topic. This one is called What are evaporation and condensation? So we're going to learn all about evaporation and condensation. The learning journey is on this slide. If you want to write it down, please pause the video. And your do now question is, have you ever been on a bus or in a car on a very cold rainy day? What happens to the windows? And maybe you already know why. So pause the video now to write down your answers. All right, in this lesson, we will learn why this happens. So I'm sure you've all had the experience of being in a bus or a car or something, and the windows on the inside all steam up with condensation. We're going to find out why that happens. So these children want to know what will happen to this puddle on a hot day. Can you tell them? Pause the video now to write down your ideas. So that puddle from the previous slide is going to evaporate. This is a diagram showing you how that happens. I'm just going to read the text. Particles with high enough energy can escape from the surface of the liquid. These form a vapour above the liquid surface. Okay, so as we know, the particles in a liquid are always moving around constantly. Now, all of the time, some of them are moving just fast enough to escape from the surface of the liquid. And when they do, they go into the air and they form a gas. Another word for a gas is a vapour. And that is a change of state from liquid to gas, and it's called evaporation. What happens during boiling? So if you don't remember, you can go back to the previous PowerPoint and watch the explanations, or if you do, you can write down your ideas now. And how is evaporation different to boiling? So we need to get the distinction between these two things. Your task is to write out these sentences and say whether they describe evaporation or boiling. So happens at any temperature. Is that evaporation or is it boiling? Only happens at the boiling point. Particles escape from the surface of the liquid. Bubbles of the substance in the gas state form within the liquid, and bubbles rise to the surface and escape. So write those out and say whether they're talking about evaporation or boiling. Pause the PowerPoint while you do that. So this is a diagram showing you the difference between evaporation and boiling. Evaporation is on the left. So you've got particles escaping from the surface. There are no bubbles forming throughout the liquid. And on the other side, on the right, you've got boiling, the liquid being heated up, and there are bubbles forming throughout the liquid, and eventually those bubbles rise to the surface and the gas escapes from the surface. So you should be able to relate that to the previous question, so use that information to check your answers. Extension. So this purple box says evaluating evaporation. Eva is investigating evaporation. She puts a small damp tissue in a cold place and she puts a big wet towel above a heater. The tissue dries first. Eva concludes that cold conditions speed up evaporation. Evaluate Eva's investigation. How could she improve it? Does the evidence support the conclusion? And your challenge is, what scientific question is Eva trying to answer? So pause the video while you answer all of those questions. All right, first of all, I'm going to answer, does the evidence support the conclusion? No, it doesn't. Because the experiment is not a fair test. She's not comparing similar things. So if we answer the question, how could she improve it? That'll help to explain. So first of all, she puts a small damp tissue in a cold place, and then she puts a big wet towel above a heater. So she's trying to compare something small with something big, and something that's not very wet with something that's very wet. So that's not a fair test. So to improve it, she could put a small damp tissue in a cold place and a small damp tissue above a heater. Or she could put a big wet towel in a cold place and a big wet towel above a heater, but that would take longer, so I would do the first option. And your challenge, what scientific question is Eva trying to answer, would be, how does temperature affect evaporation? What she really wants to know is whether evaporation happens faster in a cold place or a hot place. Evaporation is used in sweating to cool the body. So when a substance is in a liquid state, the particles are all moving around, and during evaporation, some particles gain enough energy to leave the liquid and become a gas. So they take that energy with them. So the body uses that to cool itself down. So your body produces sweat, your sweat sits on your skin, and then the water particles in the sweat evaporate from the skin, taking energy with them. And that's how sweating helps your body to cool down. So going back to our bus example, now you know all about evaporation. Can you tell me where all this water has come from? So pause the PowerPoint and write down your ideas. Well, if lots of people are getting onto this bus and their clothes and their hair are full of water from the rain, then that water will be evaporating into the air inside the bus. And on the next slide, we'll talk about why it gathers on the windows. So we can think of condensation as the reverse of evaporation. During condensation, particles of water, called water vapor, in the air lose energy and move more slowly. Eventually, they get close together and change into the liquid state. So that's what you're seeing on the inside of the windows, is lots and lots and lots of droplets of liquid water. Complete these sentences to describe what is happening to the windows on the bus. So I'll read them through and then you can pause the PowerPoint. The air in the bus is full of. This is because everybody's clothes are wet underwater. When the water vapor hits the cold window, the particles move closer to other water particles and form. So pause the PowerPoint now and complete those sentences. You can check your answers on the next slide. Alright, so the air in the bus is full of water vapor. This is because everybody's clothes are wet and the water evaporates. When the water vapor hits the cold window, the particles lose energy, so they start moving slower. The particles move closer to other water particles and form liquid water. So use that to mark your answers. Okay, as a forensic soil scientist, Lorna Dawson sometimes uses dry ice. But what is dry ice? I'm sure lots of you know the answer to this, so pause the PowerPoint and write down your answers. Dry ice is solid carbon dioxide. So it has been cooled down to a very, very cold temperature and it is turned into a solid. Now dry ice at temperatures above minus 78.5 degrees C turns straight from a solid into a gas, and that is called sublimation. So that is another change of state, but rather than going through the liquid state, dry ice goes straight from a solid to a gas. Now, you can't see the carbon dioxide because it's a gas. What you can see, the fog, is caused by water vapour in the air condensing when it hits the very cold carbon dioxide particles. And so it condenses into a liquid and forms tiny droplets, and that's what you can see. That's why it looks a little bit like steam coming out of a kettle, because it's actually droplets of liquid water. And here is a link to a video with some demonstrations about dry ice. All right, have a think about this question. What other jobs might use knowledge of evaporation, condensation, or sublimation? Pause the PowerPoint and write down your list, and you can check it with your teacher next time you're in school. Here's your summary. Evaporation is a change of state from liquid to gas. It is different to boiling because it happens below the boiling point and only at the surface. Evaporation is useful in sweating. Condensation is the change of state from gas to liquid. Sublimation is the change of state from solid directly to gas, or the reverse, from a gas straight to a solid. In America they call that deposition, but we call it sublimation. A good example of sublimation is dry ice, solid carbon dioxide. Okay, that's everything. Thank you very much, and I will speak to you next time.